Hi, I'm Bruce Morton. I'm with Entrust Datacard. We're a certification authority in the public key infrastructure industry. I've been working in PKI for about 20 years, deploying PKI to customers, and the last 10 or 11 years, I'm working at our certification authority to issue certificates. So basically, SSL or TLS certificates that are put on web servers to allow security between browsers and servers. I work with the I work in compliance. I work with the CA Browser Forum to determine the standards that we issue certificates to. I also work with the CA Security Council, which tries to provide knowledge education to try to educate our subscribers on about threats, vulnerabilities, and provide knowledge on best practices on how to deploy certificates. I was asked to come to the conference and talk about SHA1, so the hashing algorithm that's being deprecated, and we're moving on to SHA2. And I thought that, I'm not sure that hashing algorithm would be the best topic to talk about at Payments Panorama. We're talking about collision attacks and the birthday paradox and second image attacks and pre-image attacks and so forth. So I thought that's probably a little bit off the probably not the best agenda for the talk here. So really what I'm going to talk about is that we've been doing this for about 20 years. And we've been issuing SSL certificates and protecting websites, and protecting user websites for about 20 years here. And we're seeing a lot more of, I have to do this, I have to change this. So I just wanted to kind of walk you through a little bit of where we were and how we got to where we are today in the TLS industry, and really then try to tell you how you can help yourself, how you can help your administrators, and help your customers. So what we'll do, I'm just going to go. So we have 3 polling questions out there. This is kind of the truth or dare one. Now that you've heard the introduction, are you at the right presentation? But if you want, if you can go through the polling, and there's 2 other questions in there, you can answer them at the same time. That'll be fine. So anyway, and we've got to know. I don't know what happens if it goes the wrong way here. Do I just walk? Is that the dare part? By the way, I was going to title this presentation "Where We Are with TLS," but the marketing people came up with the name about Wild West and Law and Order, and I tried to change it, but the Payments Panorama said, no, that'll bring people to the session. I don't know if it worked, but anyway. Okay, that's good news. Maybe we'll just go to the next slide then. Okay, so basically, we really started about 20 years ago with our browser Netscape. Netscape developed Secure Sockets Layer, which is basically the secure protocol. They developed versions 1, 2, and 3, again, really to protect your username and password and any transactions that are going on between the browser and the server. So the certification authorities, which their job is to certify who the server is, like who's the ID of the server, do they own the domain name, do they give authentication to issue a certificate with their name and their domain in a certificate? Certification authorities were brought online to do that. So basically the rules were that collect the data that the customer wants and put together a certificate that would actually work with the browser and browsers and servers. So what we found was that, of course, there could be vulnerabilities, vulnerabilities and attacks. We didn't set what the hashing algorithms would be. We didn't set the validity period of the certificates. You could have pretty well any validity period you want. So regardless of your key strength, you could have a 10-year certificate. Again, most CAs would validate the organization name and get authentication, but one CA came in and said, we're just going to do domain name only. Do you have control of domain name or not? So we started to actually reduce the type of security that we had. So there's some worries there. Of course, there was a little bit of justice of how do we try? We basically had to take it case by case. You can almost take these two slides back and forth. Is that we found a problem, we tried to address a problem, we found a problem, tried to address a problem over and over again, right? Netscape tried to ensure that CAs were really above board. They would charge in order for us to put our root certificates into the browser. They would charge $250,000 to put your root certificate in the browser. Now that's the .com bubble days, and we paid $250,000 to do that. These days, all of these root certificates are put into operating systems, Windows, Apple OS X, iOS, BlackBerry, or into other programs for browsers such as Mozilla for Firefox. We work with Oracle for Java and so forth, and all these things are provided. They're provided to those software vendors and at no charge, and they distribute those roots for free. The obligation on our side is to follow their policies. So nevertheless, there was this. It did feel like without any rules in place, we might have been circling a little bit to the bottom of the security might have been coming down a lot. So we brought in law and order. Back in May of 2005, a number of the browsers and certification authorities got together, and it was really trying to, our big issue was phishing. And I think phishing probably hits the payment industry. It did. I don't know how much it does now, but it really hit the payment industry a lot. There was phishing attacks against PayPal, RBC, Scotiabank. All the banks would have sites that come up that sort of look like their site. You could make it even look better if you put a digital certificate on a site as well, so that the customer thinks that they're going to a site, it's got a cert, therefore you see the lock, therefore I think it's safe. But that allowed for more phishing attacks at those sites. So the idea was, can we come together and try to raise the level, raise the bar, and see what we can do to mitigate this. So we created the CA, Certification Authority Browser Forum. I think this is where the next question was. And just to see, I don't know if you've heard of it or not, but I maybe just heard of it because I said I was on at the beginning. So maybe 2/3 of people have heard of the CA Browser Forum. We'll just move ahead. So really, the CA Browser Forum is made up of six browsers, and I'll say browsers are operating systems. So we work with Windows, Apple, Google, Mozilla, Opera, and another one called WoSign, which is out of China. We have about 52 certification authorities in the forum. We're also supported by some of the audit companies. We have WebTrust and Etsy in the audit side, and also subscribers. I don't think we really get any support from Canadian subscribers. Some of just our membership are large subscribers of certificates. You think of the number of certificates that Google or Microsoft might use. Amazon is now a certification authority as well. They use a ton of certificates. So we do get a lot of subscriber input, which is really probably something we're missing, because it's the subscribers that are the ones that are impacted when they have to deploy the certs. We have about 170 million servers in the world to be protected, right? And so those are all owned by subscribers. So regardless of that, so we put together, as we move forward then to try to address the phishing problem, we established a new certificate called the Extended Validation Certificate. I don't show a picture here, but what you'll see with extended validation is that you'll get a green, up in the status bar, you get a green look. You'll see the name of the company in green. You see that on most browsers, right? So we created the EV guidelines. They came out in 2007, and we extended that to EV code signing certificates. And we were kind of rolling along with those things. But EV is really probably about 5% of the market. The rest of them are these domain name certificates where we just check control of the domain, or organization, where we check the organization, but we don't do all the other items to get to extended validation. Extended validation checks the jurisdiction of the organization, and we go through a number of steps to make sure that it was authorized to be issued. So in addition, so at the lower level certificates, we need to use the browsers or operating systems policy. So we put together the baseline requirements. Excuse me. So baseline requirements are basically took some good ideas from EV and took a lot of common elements from all the browsers and just tried to set the standards there, and we rolled this out. And what we tried to do now is try to, wherever there's no caps, we want to put caps. We said, well, we could issue certs for an unlimited period of time. We made it down to 60 months, where you could have key sizes, whatever size you wanted. We started to put in, you need a minimum key size of this. In addition to that, we started to try to roll out, I mean, it was called baseline, but we wanted to increase that baseline so we would have changes being made in the future, which is potentially what you might see with your SHA1 issue now. So of course, again, that's where you did have this impact. The impact is largely on your admins. Your admins are being told, well, they're trying to, they're asking for a certificate, and the certification authority says, well, I can't issue those anymore. The policies have changed, right? So again, we currently now issue certificates that have in RSA that have 2048 bits. It used to be 1024, now it's 2048. Again, we've changed the period. We used to issue certificates that with names in it that weren't registered. So registered name, basically you have to go and register a domain name. If I'm Acme, I might register acme.com. I put up a web service called www.acme.com. If they also want to have a mail service, I'm able to have mailservice.acme.com. If they just want to use the mail service internally, they might ask for a cert that's just called mail service. Well, you can't register mail service because everybody could have it, right? But the CAs were happily issuing certificates with just these host names in it or unregistered names, which meant that you could get a certificate and your partner across the street or someone else across the street can get the same certificate, and then one could be used to attack the other. So we did end up really kind of knuckling down and putting in the baseline requirements and then putting in items to remove problems in the future. And this also required the CAs had to be compliant as well. So we put in a lot of standards in there to make sure that we had a good base of CAs. And I did mention SHA1, so I don't know if need to go 2 ahead, I think. So I don't know again if we need the one for this question here. Maybe I'll just talk about it. Does anybody even know what a hashing algorithm is or so? So when we do encryption, when we do encryption or signing, we need to sign an object, and you can write a story, right? So you can write Jack and Jill, or you can write War and Peace. So one's this little object, one's this massive object. What we do in order for it to be more efficient, we'll basically hash that object, and put it, and so use a hashing algorithm and put a cryptographic value for that, which is a fixed length. So in SHA-1, it's 160 bits. In SHA-2, you can have 256 bits, and it can go up to 512 bits. So it's a different algorithm, but we've set, we basically showing that we just have this cryptographic number to say, to represent Jack and Jill or represent War and Peace. And you cannot go backwards. You cannot look at a hashing algorithm and say, oh yeah, well that's Jack and Jill. That's basically impossible. So in order just to make everything more efficient, everything is done with hashes instead of, otherwise you could end up with great big objects. Every time I did an object, I had to shove in War and Peace or something like that. So it's done with this type of hashing, this hashing algorithm just to make validation a lot easier. So do we have any responses on this one? Yeah, so I guess we'll just move ahead because we're not seeing it's the wrong question. It's the wrong.
Yeah.
It's one.
The link to your app, the presentation in the app also doesn't work.
Oh no? Okay. We'll have to talk to. Okay, so maybe we'll just move by this then if it's not there. And the next one. Perfect. All right, go to the next slide then. So why do we care? Why do we really care? Why are we putting in all these rules and so forth? And what we really care about is growth. We care about the growth of the industry, the growth of the number of users, the growth of the servers, the growth of the capacity of the computers and so forth. Again, and just a slight step back of what we're trying to do here is we're trying to represent, browser and server is really trying to represent the parties of buyer and seller, of someone with money and a bank, of a citizen and government. But the certification authority is trying to certify the ID of the server so that it's trusted to the browser user. In addition, the CA then will provide status of those certificates. So the certificates a key might be compromised, so we'll revoke the certificates, and we can provide all this status down to the browsers as well. So back to why do we care? We really care about growth. You can see here, I thought this was pretty interesting. So if you look at the 20 years, we've seen that the number of users on the internet have gone to about 3.4 billion users, or 46% of the population is on the internet. So in 20 years, starting from basically zero up to 46% of the internet. So a lot of users out there performing transactions. What about the computers? I was kind of disappointed when I saw a couple of presentations yesterday regarding Moore and Moore's law. But anyway, so Gordon Moore from Intel, I'll just run over it one more time. So back in the 60s, he came up with his Moore's law, which he changed in the 70s. But frankly, he was saying that if you look at a processor of a given size, that the number of transistors on that processor will double every 2 years. So your computing power, the speed, will basically double every 2 years. And you can see, if you just look and you can probably remember some of the old computers you had with these processors in them, of how that's changed. This is only going up to about 2006, 2007. But you can see, again, the number of transistors on the side is an exponential growth of transistors. And this is continuing to today. The Moore's law is still in place today. So every year, although the price of computers never come down, they always get faster. The upside is that it gets faster for the browser, it gets faster for the server, so it really has allowed more and more transactions to be done over the years, right? That in times, well, I might want to do it because it's too slow. It's just faster. All things now can, most things can be done now from the browser to the server. The downside is if you're an attacker and you want to provide a brute force attack, it's much, much easier. The attacks, we used to talk about attacks and say, well, how many PCs do I have to get in order to perform attack over 1 year? And generally, how much money would they have to buy for PCs and take 1 year to do it? Is the data going to be valid over 1 year, right? Now it's how many dollars do I need to spend at AWS over a couple of weeks to perform the attack? It's decreased that amount. That you can perform these attacks without the investment, without figuring out how to put it all together. You can just buy the, basically buy the resources from Amazon. We've seen, obviously, we've seen e-commerce growth. So this is U.S. e-commerce growth over the years. I think that was in 2014, 176 billion, and growing at about 18% per year. But we've also seen social growth. Facebook is up to 1.6 billion users. Twitter is 300 million. Gmail, if you look at online email, they're up to 1 billion users. We can add in, your Microsoft users. There's a lot more users out there. But what you're seeing in more or less of social growth or in email growth is communication. Rather than financial transactions, you're seeing communication type of transactions. So then, why do we really care? Because in essence, we kind of designed the system a lot cases on the financial side. How do I make sure nobody steals your credit card, right? And you probably know it better than I do, is that I think the industry has a lot of ways to mitigate that risk. But what we care about is privacy now. Privacy is a lot more concerning because of all the interactions of communications going back and forth. In 2011, one of the CAs called DigiNotar, it got attacked, it got compromised, it issued about a little over 200 certificates. It issued, Google.com, it issued a lot of certificates which would impact communications. When they analyzed to see, well, who got impacted here, they basically did a heat map of all the people that were asking for the status of the certificates. In that heat map, they showed about 300,000 people were impacted by this thing, but about 90% of those people were in Iran. So it was not this ended up being more or less a state attack, right? A state attack where someone was trying to interrupt the communications or see the communications, which is it's a privacy attack, and it with really no where the people have nothing in place to mitigate that risk. We also saw this extended out in 2013 with Edward Snowden, where he provided all that information about the NSA, and really what the NSA was doing was called pervasive surveillance. All of this work we do between a browser and a server, we think of that as a session. After the session's over, we don't worry about it anymore. But what the NSA was able to do was to, for a given server, just record all transactions that come to that server. Record all transactions for not now, but for a year or 5 years or something, and then they just need to decrypt the one key, just the server key, and then they can see all the data that was going to that server, right? So again, another privacy type attack. So what we've done, and I don't know whether this is. I'll just go to the next slide. This might be the results of, in payments industry you have fintech. I don't know whether we have CertTech or something, but a lot of this is just trying to overlay. How can we protect? How do we help really to protect the buyers of certificates to make sure that they know if their domain name has been compromised. and various ways to do that. So I'll just step through. It's a little bit techy here, but what the heck, I got lots of time. So we'll look through. So the first one is public key pinning. This allows the server to put a header in that says that when you validate this thing, you want to validate with this key. And in addition, we'll say that this message is good for X many seconds, which could be a month or a year or something like that, and it gets cached at the browser. So every time the browser goes back to that site, it wants to see that key. That key could be the server key, it might be the issuing CA key, it could be the root key, and you can put in multiple keys, you can put in backups and so forth, right? And this might not be the best scalable solution, but it's been a good solution to detect fraudulent certificates, and Google's used it quite often to find fraudulent certificates. The second one is strict transport security, and this as well as your administrators can put in this header as well to say that every transaction to the site must be secured. You can say this site and all subdomains, and again, it also has that time period of how long that'll be valid for, right? So, and if it's not secured, then the session will fail. And for the most part, I assume everybody in the payment industry is securing their sites, right? So you can, if you're securing your sites, you're going to that step. You can do one more step is to make the statement that the site is always supposed to be secured, so the browsers know that. Certificate transparency is interesting. A lot of these items are kind of pushed out by where Google is getting involved. So certificate transparency was developed by Google, and basically they make these we have CT logs. We have probably maybe 10 or a dozen CT logs out there, and when we issue EV certificates, they all have to be logged. They have to be logged in 2 to 3 logs. These logs they're tamper-proof, they're auditable, and they can be monitored. So if you have your domain, again, you're with Acme Corporation, you've got acme.com, you can go and monitor the logs and see, well, were any certs issued for www.acme.com? And if it was issued by Entrust, you'll probably say, yeah, that's good, no problem. But if it was issued by somebody else, maybe there's an issue, right? So you can monitor these logs. And so we will be moving. You'll probably see the industry moving so that all certificates will end up in these CT logs, and that monitoring services will be provided. And your CA will probably provide monitoring services to you. Certificate reputation is a similar item provided by Microsoft. So Microsoft's not providing public logs. Microsoft is logging the information inside. So whatever certificates that Windows sees, Windows will provide that certificate. It'll be logged, and then you can go to the Microsoft site, log in, show you how, prove that you have control of the domain, and they'll show you all certificates that were issued for your domain. So again, it's really trying to put domain protection. CAA, so Certification Authority Authorization, the CAs are not, the CAs and how they issue certificates is not hierarchical, basically meaning that any CA can issue a certificate for any or all sites. So although you're with whatever company you're with, and I have a contract with one CA, it doesn't matter. Another CA can issue a certificate for your site. There's no control mechanisms in place. With certification authority authorization, you can make that statement in your DNS record to say that this is my CA. So all CAs then, they will look at that record and determine, are they authorized or not? And if they're authorized, they'll issue. If they're not authorized, they'll either not issue or they'll go through some sort of escalation procedure to get approved. Perfect forward secrecy is how we is really the method for the method we use for the NSA pervasive surveillance. Again, we said that all the encryption was all the keys, the session keys were protected with the one key. This allows that every session is protected with a different key. So you can't record them all and decrypt everything by cracking one key. You need to crack many, many, many keys. Just a couple of other smaller items here, or different items, is that OCSP stapling. You always need to provide the status of your certificates. But one of the issues is that when you make a connection, the browser and the server make a connection, if the browser will then also reach out to the CA to find out the status of the certificate. If the CA, not saying that the CA is compromised, but when we issue a status, we issue it and we make it valid for 7 days. So we say the cert's good, and it's basically saying the cert's good for the next 7 days because the validity period is 7 days out. So an attacker can get that response and provide the status as good until it expires, right? With OCSP stapling, the server provides the status directly and kind of eliminates the attacker getting in the way. This method, it also decreases latency, which is probably another good thing. Decreases browser latency. So this is available. It's standard item for Windows users, and it can be put into other web servers. And then finally, we have basically deprecation. It's a great software word to say get rid of the old stuff. We've moved through over the years to get rid of all the old SSL, the old protocols. Sometimes confusing. I talk about SSL and I talk about TLS. It's the same thing. SSL is secure socket layer, and TLS is transport layer security. But Netscape developed secure socket layer, and then when we moved it to the IETF, then they called it transport layer security. So all of the Netscape SSL items is deprecated. That shouldn't be used anywhere. And we should only be using TLS versions 1.1, 1.2, and 1.3 will come out someday soon, hopefully. Again, we're seeing deprecations of hashing algorithms, so we're deprecating SHA1. And it's a big item. The big item, especially if you have users, some of those 3.4 billion users, is that in 2017, Windows won't support SHA1 anymore. So if your site has SHA1 and Windows won't support it, you'll have a little bit of a problem. And the other browsers won't support it as well. So you really have to move away from SHA1 onto SHA2. And there's other items as well that are being deprecated that are in our standards. Just want to touch base on how you can help yourself. We'll talk about education, security policy, reliable CA, and tools. Again, a lot of this items is just get yourself up to speed, get educated. I was talking about the CA Security Council, and just the next page, I'll provide some links and so forth. So if you actually want to check this out more, so there's a CA Security Council. Again, does white papers, does blogs, tries to get blogs out there when a new vulnerability comes out. Say this is the vulnerability, this is how you mitigate it. CA Browser Forum is really more about changing the standards. Probably not a good one to look at unless you want to get involved in changing the standards, because it's always good to have subscribers' input. SSL best practices is kind of a lot of fun. I work on that myself. I write regular blogs myself all the time. I've turned a lot of these blogs into SSL best practices. But again, the main thing is basically saying, basically information to subscribers on how to deploy SSL. And there's other contributors as well that can provide the same type of thing. Or you just follow the CVEs and analyze those as they come up. There's always a status of CVEs that come out. So with that type of information, you can create your own security policy, at least around SSL certificates, what CAs you're going to use, so that if you want to say through CAA what my CA will be, you can say what your certificate admins, who will be administrators. One of the rules we have is that if you tell the CA that this is the only account that can buy certificates, then we will not sell certificates for your domains through any other account, right? So you kind of limit it down so that we don't have rogue people coming in and buying certificates for your domain names. And you can set your key sizes and validity periods, protocols, and so forth. One item here, which is kind of interesting, is always on SSL. It's not the way to sell more certs, but the idea is that all sites have SSL certificates. It takes away the the common vulnerabilities without having the certificates. It provides a common user interface to all of the users, so they don't sometimes see the lock, sometimes they don't see the lock. It helps if you want to deploy the latest version of HTTP, which is HTTP/2, which cannot be deployed without SSL certificates. It raises your search engine optimization as well, which is always good item as well. So always on SSL, or you'll see HTTPS everywhere. This is something that Google has done a lot of, and you see a lot of companies, probably not blogs you read, but I read them, about where they've announced they're moving to SSL for all sites. From the CA side, hopefully the CA can be be a partner with you. The CA can really help you with most of everything on the right-hand side. If you don't know it, if you have questions, hopefully you'll have a CA that can provide you, point you in the right direction, provide you the information. The support team can help educate you on anything on the, I said right-hand side, but left-hand side. CA should be able to provide extensive certificate management and certificate discovery of certificates that maybe you don't know about, maybe private certificates that are issued from a private CA or self-signed certificates in your environment, maybe discover certificates that don't meet your policy, they're using the wrong hashing algorithm, or maybe you want to say, I've got a policy to move everything to this level by this time, so you can find that out with a discovery type of search. They should be able to provide a variety of certificates, and I mean all different types of SSL certificates. But if you're interested in code signing, SMIME, they should be able to provide that. And again, they need to provide basically responsive status of their certificates, globally. And then finally, just the real thing here is just to use some common tools. I'll just touch base, and I say I have some links, but SSL Server Test is just a great tool where you can just put in the domain name, and the service will run a test, and in about, depending on how long it takes, somewhere between a minute and 2 minutes, it comes back with the results, gives you a grade in 4 different areas, and if there's any issues, it provides all the issues, and it points to all the information that you can find to bring up the levels of your issues. So if you're using the wrong protocols, you have the wrong hashing algorithms, your site is susceptible to certain vulnerabilities, the SSL Server Test will help you with that. To back that up, I work with a guy named Ivan Ristic out of the UK. He's written this book called Bulletproof SSL TLS book. You can buy it on Amazon. We provide it to all of our customers for free. But basically, it's a book about this thick that just runs through web PKI from A to Z. It talks about all the vulnerabilities. And since it's an ebook, since you can get it in an ebook format, he updates it all the time. He sends emails on a regular basis to let you know if there's any issues. So you end up with an independent third party, which is providing your administrators with information in this area to help mitigate vulnerabilities. And again, certificate transparency is just an easy way to check to see what certificates were issued for my site. So that's a list of tools. Hopefully you get the presentation so you can get these list of tools and take a look yourself. I can leave that up. This is the end of my presentation, so I'm open to any questions. Anything? Yeah.
One of the areas that vulnerability is social engineering fraud, where third parties will create domain names, typically very similar to, but not identical to existing domain names, then issue emails from those domain names to controllers, internal audit, CFO, causing finances to be paid out by the SWIFT. So now, on that type of scenario, it might be something like instead of email coming from president@acme.com, it will be president@acme.com.
Right.
Net effect is they've compromised it. They're able to get in, they're able to get enough information. What, if any, tools are available to monitor and scrub emails coming from basically fuzzy logic type domain emails coming in to protect those in sensitive financial positions from being subject to social engineering fraud.
Right. So I don't know the tools, but it's interesting that the registrars of domain names allow those domain names to be issued. Right. They have a lot of ways to, if they've registered at Amazon.com, but if they see someone coming in, they swap the 0 for an O. This is an easy thing to scrub and say, no, we will not issue for that, right? But we're in a world where the registrars will basically issue whatever anybody asks for, right? Although there are tools to scrub that out. I mean, they can use blacklists to scrub it out. They can translate these names. So it's not helping to answer their problem, but we can eliminate a lot of those issues if if we just didn't issue the certificates to start with. We have the same, the names to start with. We have the same problem with the SSL side as your email side, right? Is that someone will be coming in and maybe they're going to want PayPal, where they change the L to a 1, and then that's what they want for a certificate, right? So they should never have been able to register that domain name as well. So we need to scrub it out at one layer up, and if we don't scrub it out, then potentially we've issued a certificate for a phishing site. But I don't know any tools for the email side. I'm sorry about that. So, any other questions or? Well, thank you very much for the time. Hope this helps, and be around for the rest of the day if there's any questions. Thanks.